Okay, everyone, welcome back to CSE 391. This week, we're going to continue our discussion of Git branching and talk about some and more advanced features about these things, this thing called merging, and how this all relates with your remote repository. So, kind of our one thing I want to remind us about before we go in is to think back to kind of some logistics for our syllabus. So please make sure you go back and check your homework scores, the scores on Gradescope. You know, when we publish your assignments are the scores you should get. You can also double check with Canvas. Please make sure you understand our syllabus policy for how you earn credit in this course. As one reminder, all of our assignments except these Git ones are auto-graded. So homework 4, because it's about Git, we are not able to give that an auto-graded score, so we'll grade that one manually, and our hope is to have that published to you before homework 5 is due. So today we're going to be talking about some more Git stuff, including branching, merging, and working with these remote repositories. This is going to be our last week on Git, and then we're going to start transitioning into more applied, other applied aspects of Linux tools, primarily talking about these things called regular expressions. So as a reminder, when we're talking about Git, Git is a version control software. And Git can be a bit weird to get used to at first because it has a lot of terminology that goes along with it and multiple steps along the way. So we talked about in Git, there are kind of 4 phases of any changes you might make and where they will live kind of as you develop and as you start adding to this version control system. So you start with the working directory, which is kind of like just your file system on your computer. You can make changes, save files. That's like your working directory. Saving files here does not add anything to Git. The staging area is kind of where you go to say, I want to commit this thing. So you're getting ready to make a commit. You're saying, these are the changes I want to include in the next version I make, the next commit I make. Then when you do a git commit that actually takes all of the changes in the staging area, reminder, we also call this the index, so interchangeable terms there. It takes whatever changes are there and moves them to the local repository. It makes a commit, it makes a new version of the project that adds to the history, and you can always look back at that later. And then this doesn't share your work with anyone. This is just editing your local version of the repo. If you want to share those changes, then you got to push those changes up to the remote repository. So far, we have been doing everything in Git on this thing called the master branch. We kind of ignored, you might have saw that word master pop up a couple places in some of the Git commands, but we haven't really talked what that is. Git has this notion of branches where you can kind of have, in some sense, like different streams of directions you might be working on your project. So you might say like, you're working on a project and you say like, oh, I want to go work on this feature. So you essentially kind of form your own history. It kind of branches off from the main history. You go work on something for a while. Other people can review it. And then when you're ready to kind of push those changes, kind of add those changes to the main project, you can do this thing called a merge, where you take that branch that forked away and merge it back in. We'll talk about that more in detail. However, if you're thinking about working on a large project with many people, it's very rare that you're actually going to be working on master directly. Instead, it's very likely that you'll work on one of these feature branches, kind of this split point of the project, and kind of form your own history for a bit before kind of merging that back in. Why do we do this? Well, it can get a little confusing if everyone's working on master at once. A lot of people like to think of the master branch as kind of the source of truth. It's like the official version of the history of the project. And usually most companies or most groups that work together like to think that everything that's in master should be stable and compile. So actually a lot of build systems actually check before you're even able to make a commit that goes into the master branch, your code must compile, and it will just completely break the system if your code fails tests or it doesn't compile. And so this kind of keeping this master in this really clean and stable state makes it really hard to share potential changes and collaborate with others. And so this kind of notion of Git branching really makes it simplifies a really complex story in terms of everyone working in one place. Everyone can work on their own branch. You can share changes between branches. And your changes to branches don't necessarily affect this master branch. So before I can show you how these branches things work, I have to kind of solidify a little bit more some of the terminology we've been using about Git so far. So we've talked about how every time you want to make a new version of your project, you make a commit. When you commit something, it takes all of the changes in your staging area and bundles them up into a commit that gets added into the history. Usually, we think of commits as being this kind of linked list structure, where you have commit A, followed by commit B, followed by commit C. Now, kind of confusingly, we always draw these arrows on the commits going backwards. We always think of a commit referencing its parent commit. So B came after A, so we think of an arrow pointing from B to A to say that A is the parent commit of B. Similarly, if the commit C came after B, it has an arrow pointing to B. So the way we always read this picture is first A, then B, then C. Now, we also like to think about kind of having a reference to our particular commit. So you probably saw on that last slide, I had these two boxes here, the kind of goldenrod box that says head and the salmon colored box that says master. So master is the name of a branch, and a branch is essentially just a series of commits. You could say the master branch has commit C, and before that was B and A. So master is just a name of a commit, essentially. It's just saying, hey, this our official version of the project history goes C, and then before that B, and then before that A. We'll also see that there's this common thing in Git called head, which is basically just a reference to tell you which branch are you on right now. That's not going to make a lot of sense quite yet. It'll make more sense when we introduce other branches. So this picture is one we're going to have in our head, but let me do a bit of a demo here so we can talk about this. So what I have here is I have set up a little repository. I'm calling it ABC. The reason is all of the commits and edits I'm going to be making are really small. It's supposed to be very simplified, so we can kind of understand what's going on here. So to make this a bit clearer, I've made a repo called ABC on GitLab, and I've added a file called file.txt that currently has the lines. If this decides to load, my computer's kind of slowing down for a second. This has the lines A and B. And so far I've added two commits, one commit called A and one commit called B. To make that a bit clearer, I've just cloned this repo on my computer. If I type the git log command, it shows me the sequence of commits. It shows me first commit B, and then before that was commit A. This is kind of showing you this linked list structure without actually drawing any of the arrows. Now notice that when I showed you git log last time, I actually told you to ignore a fair amount of this. Remember, this is our commit hash, which is the unique identifier for the commit. It shows you your name and your email and when the commit was made. But up here, it shows you some really useful information. So what it's saying here is it's saying head is referencing master. And it's also saying this thing about origin master. We'll get there later. You could just ignore that part for right now. But this git log is showing us where we are right now in the Git world. This is where head is. This is currently referencing the master branch. And this master branch is kind of attached to this commit right now. To show what happens when you actually make a commit, let me actually flip over to my slides here. Kind of our goal right now is to make a new commit C on the master branch, kind of this main branch. So let's go ahead and do that. I'm going to go ahead and say vim file.txt. I'm going to add a new line C. I'm going to save and quit. And now if I do git status, it will show me that I have a current unstaged change. So let me go ahead and stage this. Git stage file.txt. And then I'm going to go ahead and commit this. I'm going to go ahead and here and use the shorthand version for commits because all my commits are just going to be a single letter for this example. I'm going to say git commit C. If I do git log, now we can see that C is the new commit as a new hash, and it's showing me that I've just made a change to the master branch. So head is still pointing to master, but now master's here. one thing that I want to, and again, just ignore that origin master for just 1 second. We'll get there in the next video. So head is now pointing to master. What I've just done was I've just now made my kind of repo history look like this picture now. Previously, master and head were on this branch, on this commit B, and now I just made them on this commit C. Great. So now we're going to start talking about branching. So I have this cute GIF of a dog that is kind of doing some math with branches, because we are going to start doing some branch math. We're not actually going to use math, but we're going to be using branches quite a bit. So branching is essentially a way of saying, I want to make another series, another history for this project. I kind of want to have a separate version of history from master so I can work on it on my own. Now, the way we do this in Git is we use the command git branch. And I'm going to maybe say something like feature. I'm just going to call this branch feature. Suppose, I'm working on a project with a coworker and I want to kind of go build my own feature for a second. I don't want to work on master right now. So what this is going to do is make a new branch called feature. So I'm going to press enter. Now, if I show git log, it's going to show me that head is pointing to master and feature is here. The way you should read this is that both master and feature, they're two separate branches. They're both currently on this commit C. Additionally, the branch that we're on, head, is currently on master. This is kind of saying right now that whenever your head is pointed to something, this is saying if you're ever going to make a commit, this is the branch that is going to change. So right now, we are still on the master branch. Any commits I do from now on will still go into that master branch. But what I want to do is I want to make a change to the feature branch. I want to add a new commit on this separate branch that doesn't affect master. So the way I'm going to end up doing this is I have to say git checkout, and then I want to use the branch feature. Now, checkout here is a way of saying, hey, please give me this new branch. Now, let me show you a couple things. The way I set up my terminal, it actually shows me a little bit of Git information on my terminal in the command prompt. So you could see before I was on the master branch, and now it's on this feature branch. Let me show you, if I do git status right now, it tells me right here, hey, you're on branch feature. And let me show you to be more explicit, if we go to this git log, you could see here that now head is pointing to feature. Notice I haven't changed any commits yet. Feature and master both reference this commit C, but what I've changed is I've changed head. Now head is on feature. So if I'm going to make any commits, they go to the feature branch instead. Now let me make this a little bit clearer. If you're thinking about this a little bit more visually, what I've just done here is I've kind of made this picture where now feature and master are both referencing this C commit, and head, because I've checked out feature, is now referencing feature. So what I want us to do is I want us to make a commit to feature. I want to add a new commit called D to feature. So let's go ahead and try that. So I'm going to make an edit to the file, file.txt. I'm going to add the line D. I'm going to save and quit. And now if I do git status, it says, hey, I'm on branch feature. I have this unstaged change. I'm going to go ahead and stage that, stage file.txt. I'm going to go ahead and commit that, and I'm going to commit it to have the commit D. Okay, take a second. If I'm about to type git log, what do we think this is going to end up looking like? How is this going to be different than what we saw before? Take 1 second and think about that. Okay, so now I have a new commit D that came after the commit C. Now notice that these things in the parentheses, the branches and the references, are telling us a lot of useful information. It's saying that, head was where feature is because I checked out feature a few minutes ago. This is the thing that currently is on this commit D. Remember, the master branch in some sense got left behind. Because we never made a change to master, master just sticks on where it was before. It just says it's still on this commit C. So what I've just done here is I've gone ahead and made this kind of picture here. By making a new commit on the feature branch, I've kind of advanced the future of the feature branch without modifying the history of master. So master is still kind of in the state where C was the last thing, but now feature kind of has D as the last thing. And I can keep going, potentially build more features, add more letters, I guess, in the case of this example, that I've can add things to feature, and I can work kind of completely independently of master. Now, importantly, I want to mention everything I've done so far has not affected GitLab one bit. Notice I never pushed any of the things I've done yet. I never pushed that C commit. I haven't pushed anything about this feature branch. So GitLab is kind of all the same. We're gonna ignore the GitLab stuff for this video. We'll talk about remotes in the next video. To maybe make this a little bit more clearer, so I think this visual picture of Git commits and references to branches is really helpful. There's actually a trick you can use in Git to kind of get a picture that looks a little bit more like this, not exactly. So if you type git log --graph --1line, this is going to try to show you a visual picture of this commit. And so it's saying kind of each one of these stars is a individual commit, and it's saying D, and before that was C, before that was B, and before that was A. And it's showing you kind of a shorthand version that head is pointing to feature, which is on commit D, master is on commit C. So this picture will get a little bit prettier when we start doing some more complex things with these branches, but this kind of command is a nice way of getting a visual picture of what is going on here and how similar it is to that picture version. Okay? So now, next thing I want to do. I want us to go back to master and add a new commit E. So I want to say like, okay, maybe I need to do this immediate bug fix to master, ignore that feature I'm working on for a second. Let's just go back to where master was and make this new commit E. So we're going to go ahead and do that. To get back to master, because remember, since if you see where your head is, currently my head is saying it's on branch feature. If I make any commits now, it's going to be adding those commits to the feature branch. To get back to the master branch, that's how we use that git checkout command. So I'm going to say git checkout master, and that's going to go ahead and put me back on that master. If I do this git log, where did that one? Oh, I hit it. Git log --graph --1line. It's going to show me kind of this visual picture of the commit so far. Notice there's something missing. It's not showing the D commit. Why? Well, Git is making a design choice here that whenever you use git log, by default, it always works from the perspective of where your head is. Because it would be really confusing if you had a really large repo with lots of branches and lots of commits, if every time you did git log, it showed you all of the commits instead of the relevant ones from wherever your head is right now. So here it's showing me only the commits starting from head and going earlier. Same thing if you just do that regular git log, it will show you the exact same picture, just a slightly longer version of this. So let's go ahead and add a new line to this file. So I'm going to do vim_file.txt. Notice there's no D in this file. Why? Well, because that D change happened on that other branch. On master, it has no idea this thing happened. So this change has not happened in this version of history. So I'm going to go ahead and add a line that says E. I'm going to go ahead and stage this commit. Stage file.txt. I'm going to go ahead and commit it and give it the commit name E. Let me go ahead and show you that this commit E is there. Master is now moved forward by one commit. It is pointing at E. And head is currently referencing that. Now, if I just to kind of drive this point home, if I go back and check out feature and then do git log, notice it doesn't show me the E commit because from features history, there's no such thing as E. This is exactly what this picture here is saying. Whichever branch you're on is kind of like you're kind of looking back in history at all the commits starting from that most recent commit. So on master, the most recent commit is E and its parent is C. So it thinks the version history of events went E, before that C, before that B, before that A. But feature is kind of on a slightly different history. It says that the most recent commit was D, and the thing before that was C, B, A. And these slightly different versions of history can actually be really, really helpful when you want to develop separately. Now, in the next video, I'm going to talk about how we get changes back into master. Like, what if I've been working on this feature for a really long time? I'm ready to kind of ship it. How do I get these changes from feature back into master? We're going to use this thing called a merge to do that, which is kind of the opposite of branching. But again, we'll get there in the next video. But kind of importantly, remember, we have these commits that are kind of this linked list of changes. Then you can have a branch which refers to a particular commit, and your head is kind of which branch you're on right now. So these terms we'll be using quite frequently, so those are really important to get down.